Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. An achiral object is one that is superimposable on its mirror image, i.e., it possesses an internal plane of symmetry or other symmetry element like a center of inversion or an improper rotation axis. Moving on to the next step. Two cubes joined together forming a rectangular cuboid. Although a single cube is achiral, has planes of symmetry, two cubes fused along a face form a rectangular box. A rectangular box does have planes of symmetry, so it is achiral. However, one must look carefully. The image shows two cubes joined in a specific 3D perspective that may suggest achiral arrangement, but in general a rectangular cuboid is achiral. Moving on to the next step. A human hand. A hand is chiral. The left hand and right hand are non-superimposable mirror images. Therefore, a hand is chiral. And for the final step. A human figure, person. The human body has an approximate plane of symmetry, a vertical plane dividing left and right halves, bilateral symmetry. When viewed as an idealized figure, the human body, front view, has a plane of symmetry bisecting it into two mirror image halves. Unlike the hand, the whole human figure, as depicted schematically, is approximately superimposable on its mirror image because the left-right symmetry makes the mirror image look the same. The schematic stick figure shown has a plane of symmetry passing vertically through the center, making it achiral. 3-methylheptane has the structure CH3, CH2, CH, CH3, CH2, 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 CH3. The carbon at C3 bears CH3 group, H, a propyl chain, C4, C7 and an ethyl chain, C1, C2. Weight C3 bears CH3, H, CH to CH3, from C1, C2 side and CH to CH to CH to CH3, from C4, C7 side. Since CH to CH3 is not equal to CH to CH to CH to CH3, and the other two substituents are CH3 and H, all four substituents on C3 are different, making C3 a chiral center. Therefore, 3-methylheptane is chiral. The human figure, option C, possesses a plane of symmetry, bilateral symmetry, making it achiral. The hand, B, is chiral. 3-methylheptane, D, has a chiral center and the two-cube shape, A, could be considered less symmetric than the human figure in this context. The idealized human figure has clear bilateral plane of symmetry and is the best example of an achiral object among the choices. Therefore, the correct answer is C. Therefore, the correct answer is option C.